Okay, so our purging is finished here with the CA cabinet. So I'll just open up our latches here and we'll remove our samples. We'll just set them aside here for now and then we can have a look at them with the camera momentarily. Okay, so we'll just go over by bending bit here and I'll just show these up here. So not much problem seeing the prints here, very clear. Now there is a little bit of a curing that goes on because they are polymerized or plasticized prints. It still has a bit of time to complete the curing process, but they're pretty stable at this point regardless. You simply would, if you were to wipe your hand lightly across the surface, you would feel the texture of the ridge detail from where the glue has adhered to the ridges. Probably fairly stable too, that you would, if you handled it gently, you probably wouldn't be able to wipe the prints away. Once it's cured after several minutes, they're very stable. So there's the tin foil. Here you can see the prints on a clear piece of acetate. And on the bottle I put prints on here. I didn't really clean the bottle off. It's a little bit more difficult to see the prints, especially with the moisture that's inside the bottle, but there's prints in and around this area here as well.
Up here.
All right. So we're going to process, as I mentioned before, seeing the contrast between the white developed fingerprints and the background is sometimes not sufficient for identification usage, but for our purposes here, obviously you can see the contrast of the print without it, but for demonstrative purposes and to illustrate it, we're going to use some dye stain on the prints, and then we will look at it under an alternate light source when we're finished. So to give a reasonable comparison of the three dye stains, because they will all use their peak fluorescence will be different wavelengths of light. We're going to take our tin foil, subdivide it into three different samples, and then process each one with one of the different dye stains and alternate light sources. So I'll just quickly cut the three sections here, and then we can start that process. Okay, so we've got three different dye stains that are commonly used. This is Ardrox, which primarily will react, its peak range would be in the ultraviolet range with a light source. No goggles other than UV protection is required when using this, and it is a yellowish color, and we'll get a yellow to green color fluorescence with the ultraviolet light. Generally within the 360 to 385 nanometer wavelength range. The next sample we have here is Rhodaman 6G. This was specifically designed to be compatible with a laser at a 514.5 nanometer wavelength. It will suffice with an alternate light source in that range, so we have both a 505 and a 530 nanometer wavelength. We will use both of those as a trial, and this gets used in conjunction with a KV550 orange barrier filter or orange goggles. The third one here is basic yellow 40. Again, you can see the yellow color to it, and this you may get some visualization under a natural light, but it will also work with mid to higher visible wavelengths, so in the range of between 450 and 530 thereabouts. We should see some fluorescence with this as well. Okay, so we have set aside our three samples of the aluminum foil. We're going to start with the Ardrox first. All of these chemistries are designed to either spray or dip the exhibit in, so we're going to just spray it. We've got a waste tray here, and so we're just going to spray it until it basically runs freely, kind of flowing down and rinsing into the tray itself. So we'll let that set aside to air dry. The next one here is going to be the Rotamin 6G. And Rotamin is, you obviously can't see it in the blue container, but it is a kind of almost a fluorescent orange pink kind of color. So we're going to spray the next sample with that. And the third one here is the basic yellow. And what we will do with these three samples is we are going to use distilled water just to rinse them off. Arguably, sometimes using a methanol rinse is more successful, but we'll try it with the distilled water first to see how we make out. And all we're doing here is just rinsing off the excess from the background. Now we'll set those aside for a moment until they air dry. Now you'll notice that your screen appears to be orange. We've affixed a KV 550 orange barrier filter to the front of the camera to block out unwanted wavelengths and allow the fluorescence from the 455 to react with the chemistry that's impregnated into the fingerprints. So we're going to turn the lights off now, and then we're going to see if we get any kind of a reaction with the light source.
So now you guys will see how each of the fluorescent dye stains that we applied will be visualized using the different alternate light sources. Some of them will fluoresce or produce color at all of the different light sources, but some of them are going to be much more intense at a specific one. Okay, so the alternative light source that I'm using right now is 530 nanometers. It is a green color, and when applying it to the Ardrox, this is the color that you see. When applying it to the Rotamin 6G, that one lights up quite brightly. As for the brilliant yellow, as for the basic yellow, we're going to try now with 505 nanometers. It is a teal, blue, green color. That's what you may see there. For the Ardrox, this is how it looks like with the Rotamin 6G. And here is how it looks like with the basic yellow. And finally, we have 450 nanometers. It is a blue color. This was the Ardrox. Here is the Rotamin, followed by the basic yellow. Lastly, we will visualize it with ultraviolet light. We don't need the orange filter anymore. So now back to regular lighting conditions. We're going to take our ultraviolet alternate light source and apply it to the Ardrox, and you can see it's green-blue emission. The rhodamine is a very faint yellow color. As for the basic yellow, also has a similar green-blue color produced. So while for most of them, they all fluoresce, some of them just have a particular wavelength that creates the most brilliant color or the most intense color.